me see.
Okay. Just want to make sure everyone sees my slides.
Yes, we do.
Perfect. Okay. Thank you so much, Dietmar, and everyone else for this great workshop. And so I want to add a little bit more to the philosophical dimension of the workshop by presenting this paper titled "The Use and Misuse of Counterfactuals in Fair Machine Learning." This is a joint work with my colleague Andrew Smart from Google. And the motivation for this work came from us meeting in the New RIPS conference in 2018 and seeing all these works on counterfactual machine learning. So I was a student in philosophy of science in Toronto at the time, and I was actually taking a course on causation and counterfactuals from the analytic philosophy perspectives. And then I talked to some of these computer scientists, trying to see how my understanding of counterfactuals maps to how they are talking about counterfactual explanations. The more I asked questions, the more I was kind of disappointed in getting good answers, maybe for various practical reasons. But that motivated me trying to like bridge two kinds of literatures, one from philosophy and the other one from computer science together. So that is the result you see in this paper. So there's been this widespread attention and use of counterfactuals in machine learning community, especially for considerations of understanding fairness and explainability. So we had a lot of great talks today talking about statistical fairness, but as other authors also mentioned, there's also the notion of individual fairness. And individual fairness is a very, very difficult notion to make sense of in real life, because we need to provide the distance metrics between two individuals in the real world, and God knows what that means. But one way trying to make sense of this individual fairness has been trying to make sense of it in terms of counterfactuals. This is a famous work of Kushner et al. And other people who built on their work, the work on some of their variations. The other way to think about the use of counterfactuals in machine learning community has been in the discussions of algorithmic explanations. And of course, again, explainability and transparency, as again other speakers mentioned, relate to like the ethical dimensions of developing machine learning systems. And so in one of the most famous papers on this area by Wachter et al., they kind of make a case for algorithmic explainability in terms of counterfactuals, and they make it connected to the discussions of right to an explanation. So if we buy into the idea of counterfactual explanations for various social scenarios, like our acceptability of this notion will have legal impacts. Okay, so again, as I mentioned, there is a surprising lack of engagement with the philosophical literature on this topic. And in particular, there are two very important aspects that we think we make a case for in this paper that computer scientists should really pay attention to in order to appropriately apply counterfactuals in their machine learning practice. So one is considerations of ontological conditions that I will discuss shortly. And the other one is considerations of epistemological semantic conditions. Again, keep in mind that these counterfactuals are statements like, if Nora's annual income has been $60,000, she would have received a loan. Or if Nora had not been Latina, she would have been granted admission. So we have these kinds of statements, and the reason that they're like one very important thing about these statements is that we need to assess the truth value of these statements, whether in a deterministic way or in a probabilistic way. Okay, so just let's not talk about that. I skipped through this, so I go back to it quickly. So the idea here is that when we do not assess these ontological conditions and these epistemological/semantic conditions for grounding the elements of counterfactuals into the social world, then we might end up having some misleading results, basically. So what we do is that we did a survey of papers, mainly from philosophy, about the ontology of social categories. We focus on the conception of race just as an exemplar, but with some modifications, you can kind of adapt our arguments to other social discussions. And we realize that sometimes if we end up using this counterfactuals in the social domain, we end up requiring an incoherent theory of what some social categories are, or we end up completely ignoring other contributions of other disciplines. So basically, we would not be intellectually humble to what other researchers and disciplines have contributed to our understanding of humans and counterfactuals, basically. Okay, so let's go to the discussion. So here we are talking about counterfactuals in terms of statements that have two parts. One is this if part, we call them antecedent. The other one is the second part coming after comma, we call consequent. Like in mathematical terms, we can sometimes interpret the probabilistic statements, conditional probabilistic statement in terms of conditionals, but this is just an English version of those statements. And so the idea here is that assume that the fact is that Nora's income has been $40,000 and she was rejected for this loan application. Then we want to know if her annual income has been 60,000, so it hasn't been 40,000, it has been 60,000, well, had been 60,000, whether she would have received a loan. Or if she had not been Latina, so assume that she is Latina, and then her admission, she hasn't been granted admission. Now we want to assume if she had not been Latina, whether she would have been granted admission. So basically, when we do a counterfactual analysis, we want to know whether this fact, Nora's being Latina, counterfactually depends on herself having get an admission. And so this counterfactual dependence, interestingly, in many of the discussions, are equated with causal dependence, but it is not very clear. So for example, there are discussions about local counterfactual explanations where people don't use causal models. And so there we have a little bit of a more liberalism in interpreting what these counterfactual statements are. But the fact is that the notion of counterfactuals and causation always like very much go hand in hand. Okay, so now the idea is that in the machine learning community, when we did this survey of various different kinds of counterfactual explanations, normally people make sense of these counterfactual explanations, again, the machine learning community, in terms of feature-based explanations or prototype explanations or example-based explanations. And the idea is that always they compare one actual word, one particular state of the fact that we know about, and then they compare it with some other possible situations. So in philosophy, there are two ways that in the contemporary literature, people discuss different approaches to analyzing counterfactuals. And our claim is that all these ways that computer scientists are talking, the way they talk about counterfactual explanation, can be rooted conceptually in one of these two approaches. The one we call, the first one we call the close enough possible words approach. This is a little bit of a deviation from the main account that is called the closest possible word approach. But we just realized that because there are lots of problems with the closest possible word approach that I mentioned quickly, computer scientists don't buy into that, and we totally understand why. And then the other one is a causal modeling approach that Pearl and other people kind of promote. So the closest enough possible word approach mainly can be understood in terms of the local counterfactual explanations like Lime framework, for example, or other frameworks. And the causal modeling approach is the approach that, for example, Kushner et al. Use in order to make sense of counterfactual fairness. Okay, so the close enough possible words approach is that, as I said, you take an actual scenario in which X and Y happen, and then you kind of choose the similar enough words to the actual word in which X does not occur. And then you want to know if in those words Y also does not occur, then the counterfactual is true. Just I want to say word here is a kind of a metaphorical statement or a conception. So it's something like scenarios. So Dietmar very nicely mentioned, for example, this example for Brisha Borden. So we say, let's assume like if she hadn't been black, right? And so we assume that we can even imagine this, as he mentioned rightly. One simple way to think about that is to think that, okay, we assume that everything else is similar, but she just had been white. And in practice, maybe, or maybe like in like formal words, when we write it, it makes sense because we just need to switch a 0 to 1. But in reality, when we want to interpret this statement back to the real world, like it is very problematic, and we need to really make sure that we understand what does it mean to keep everything else about her fixed and just change her color or race. And whether we are allowed to do that, you know, like who are we to just make these kind of changes. And the other approach, I'll just quickly go over it, is a causal modeling approach that I think most of the people are familiar with. And that's a case where you're having a causal model, you're having a couple of random variables and structural equations that kind of capture the dependencies, functional dependencies between the endogenous variables. So here is a statement of what a counterfactual fairness is by Kushner et al. So they say counterfactual fairness captures the intuition that a decision is fair towards an individual if it is the same in the actual world and a counterfactual world where the individual belongs to a different demographic group. So when you want to talk about this counterfactual word, you exactly need to bring in this close enough possible word semantics, in the sense that you need to pick one counterfactual word or a set of counterfactual words among probably uncountably many or uncountably infinite counterfactual words. And the choice of these counterfactual words that we choose basically affect what is going to be the truth value of the counterfactual statement. So it is very interesting that like these considerations of which set of counterfactuals we choose completely impact, first of all, whether we can find a truth value for counterfactual, and second of all, whether this counterfactual is going to be true or false. So two sets of problems. One are ontological problems that computer scientists need to take care of. And those are questions about manipulating what. So normally we just wash off what is race and what is gender, or we just say, okay, like social scientists should care about them. And maybe we are not so much interested in making sense of those categories. But the truth is that if we just refer to what social scientists think these conceptions are, then first of all, not the whole social science community has the same agreement about what these social categories are. So for example, there's been this like historical conception of race where people wanted to understand humans in terms of the race of humans in terms of some discrete categorizations, only in terms of their biological characters. There are lots of problems with this view. And after that, there were some radical racial skeptics who came and say, oh, race doesn't exist, it's just a social construct. And then there were people who wanted to kind of be racial constructivists. So they said race exists, but okay, in the social domain, and that's a social category that we posit in order to abolish different kinds of injustices. So if you are a racial skeptic, like assuming that Brisha Borden, if she has been white, like even talking about her race doesn't make sense. So making sense of, or actually evaluating counterfactuals where you are manipulating the race of a person just doesn't make sense, right? If you're a racial constructivist, then things are super tricky, and maybe we have to be very careful in the same way that Dietmar and other speakers were suggesting, that like we need to think about the real causes or the real reasons for which like, for example, she has been categorized as like a high-risk person, not really about her race, but other features. So the idea here is that depending on different conceptions of social categories, you might not be able to evaluate a counterfactual, or you might end up having different truth values for what counterfactuals are. And so that would say that the use of counterfactuals in the machine learning system would not give you robust results, and that is going to be problematic. So the second set of problems are kind of epistemological semantic problems, and they talk about the similarity between words. So we assume, or it seems that sometimes when I read this machine learning papers, like the researchers just go very quickly over which similar words we have to choose. But the fact is that there is no view, there is not a view from nowhere. Always there's a view from somewhere, and we always have various practical and epistemic reasons to say, okay, we want to choose this particular set of words as counterfactual words, as words that are close to the actual word. And sometimes when we question those people why or give us justifications, they don't have justifications. It's very difficult to give justification. So here again, the most important problem with this set of epistemological semantic issues are really this inherent vagueness that is associated with the notion of similarity between possible words. Like, philosophers have really wrote lots of very interesting papers on these topics. And so we just wanted to point out that we have to really focus on this particular issue. And so then, depending on, again, what kind of possible words you choose, you end up assigning different truth values to counterfactual statements. So this is a kind of an epistemological problem. But okay, so far it was all criticism, but then we thought, okay, we are also not at a position to say, this is what social categories are. This is a very, very difficult problem. And this is something that maybe is context sensitive. So we thought if we want to provide a positive contribution to the literature, probably we would just provide a list of assumptions or hidden assumptions that computer scientists should check, should become very clear about. And maybe in order to answer to all these assumptions that we kind of listed in terms of questions and some examples, they need to advise with other colleagues in social sciences or in sociology and anthropology. And then when they got very clear on these kinds of assumptions, they would realize if these hidden assumptions are problematic or if they are just okay. So we won't have a perfect answer, but they're at least very clear about these kinds of assumptions. So I don't know why this slide is not very clear, but if you refer to the paper, the formulation of the table is very nice there. So in summary, we provided a criticism of the use of counterfactuals in machine learning practice in terms of, well, there is no conceptual analysis or conceptual rigor on the use of these notions. And so we have basically machine learning community should reflect and specify the hidden assumptions, two sets of assumptions, ontological and epistemological semantic assumptions, before using counterfactuals. And sometimes if we realize that there's a kind of an ethical harm for using these notions of counterfactuals, in the sense that we have to make weird assumptions about social categories, and we think they would have ethical and legal problems, then maybe even though it is very tempting and interesting to use counterfactuals, we shouldn't use counterfactuals. Okay, so thank you so much for listening, and looking forward to hear your thoughts.